Hi students, welcome to this new video of tutorial 9 where together we will answer question 6, which is focusing on quadratic forms. Now it says identify the curves 12xy minus 5y squared equal to 36 by reducing the equation to a standard form. Give the direction of the new axis and sketch its graph. And secondly, modify your working above to reduce the equation 12xy minus 5y squared plus 24x over square root 13 plus 16y over square root 13 equal to 32 to a standard form and sketch its graph. Now, let's have a look on how to solve this equation. Now, remember that for a quadratic form of two variables of the form ax squared plus 2bxy plus cy squared plus bx plus ey equal to minus f, its equivalent into a matrix form is written as x, y, a, b, b, c, x, y plus d, e, x, y equal to minus f. You can quickly realize that you have b here and b here. Therefore, this matrix A, this matrix is symmetric, so it is diagonalizable. Okay. Now, we have an equation in front of us, 12xy minus 5y squared equal to 36. Applying this, writing this equation in this form, we will have that x transpose of 0, 6, 6 minus 5, right, of x equals to 36, right? Now, having this, I can realize that this is my matrix A, so I have that A equals to 0, 6, 6 minus 5. Then, and I have that x is xy. Then I have that x transpose is xy. Okay, if everything is set and it's good, then we can move on. Now, having this, I can then solve for this matrix, finding the determinant and find the eigenvalues and the eigenvectors. So if I solve this equation to find the eigenvalues, I will have minus lambda 6, 6 minus 5 minus lambda, right? So this will give me minus lambda minus 5 minus lambda minus 36. So this will give me 5 lambda plus lambda squared minus 36, right? And then this will give me lambda minus 4 times lambda plus 9. So equaling this to 0, we have that two value of lambda equal to 4 and lambda equals to minus 9. So we have two values of lambda. Then we can then find the eigenvector, right? So for lambda equals to 4, we need to solve this equation to find the eigenvectors, right? So if then we apply this equation, right, and then for lambda equals to 4, you will easily have that. If I write the augmented matrix here, you will have minus 4, 6, and you will have a 6 minus 5 minus 4 minus 9, right? Then if you apply the Gauss reduction method here, that is, I can simplify this. If I divide this by minus 2, I will have 2. I will have minus 3. If I divide the second row by 3, I will have 2, and I will have minus 3, right? So I will have this. Then I can therefore, from here, you can see that if I do that R2 equals to R2 minus R1, so I will have 2 minus 3, 0, 0, 0, 0, right? So I will have that x1 equals to 3, x2. So my vector v1 will be 3, 2, right? I can put alpha here. for any alpha scalar. Now, for lambda equal to -9, you can do the same procedure to have that your second vector will be -2, 3. I put beta here, and beta is a scalar. Now, once we have that, we can therefore have the eigen, no, the P matrix, right? Which is the matrix of the eigen vector. So I have 3, 2, and I have -2, and I have this, and the G matrix, I have 4, 0, and I have 0, -9. Now, therefore, since A is a symmetric matrix and A is diagonalizable because we have two distinct eigenvalue and two distinct independent eigenvector, therefore, we can then find the orthogonally diagonalized matrix Q, right, which will be equal to this, right, which is simply the matrix, right, of the normalized eigenvector, right. You may ask yourself where this 13 coming from, but if you normalize V1, for instance, right, you will have that it will be 1 over 3 square plus 2 square, right? Then 3, 2. And this will give you 1 over 13, 3, 2. Right, so we have the matrix Q. Then now we have orthogonally diagonalized our matrix. Now what we do is that we find new axis. Right, and to introduce new axis, we let that x equals to q capital X. So this is the old axis, and this is the new axis. Therefore, we will have that x equals to x y, and then x transpose is x y this way. Therefore, from this equation, we have that the x transpose is equals to qx transpose, which is also equal to x transpose q transpose. Now, remember that we had this equation. We had this equation here. This equation here. We can then sub in. We can then sub in that equation. I can rewrite that equation here, which was 0, 6, 6 minus 5, x equals to 36. We can sub in this equation here, and we have that it is x transpose q transpose a times q x equals to 36. Now we see that this equals to d. So this will be x transpose and x transpose x equals to 36. Now I can rewrite this like this, xy times 400 minus 9 xy equals to 36. Now this will give me 4x squared minus 9y squared equals to 36. Now, which type of equation is this? This is an hyperbola, right? So I can easily plot this hyperbola, isn't it? So if I have this, right, I can plot this. So when I look at this equation, I realize that when y equals to 0, right, x equals to plus or minus 3. So if I have like this here, minus 3, and I have like this here, 3. So this is how my hyperbola will behave. And I will have this, right? And then I will 0, then I will have this, right? Yes. Now, if we want to find a new axis, right? If we want to find a new axis, what will we gonna do? Now, to find a new direction, we can remember we said that we let x equals to q y. Then to find therefore the new direction, we need to find the new axis. So if we do q times 1, 0, right? We have that q is 1 over 13 times 3, 2 minus 3, 2, 1, 0, which gives me 3, 2. And if I do the same, 0, 1, this will give me 1 over square root of 10. This will give me 1 over square root 13 of minus 2, 3. So I can therefore, so I have a 2, I have 3, 2, so I have 3, 2 here, and I have minus 2, 3. So here's where I'll plot my new axis this way. So I'll have my new axis this way. So this will be x. And then I'll have my new axis here. This will be y, right? So then I will have 1, 2, 3. This is 3. Then I'll have 1, 2, minus 3. So my hyperbola will behave as this. And then here, right? So you can see that this is the hyperbola that I've from the new axis, right? I think this is quite clear and understandable. Now, you are asked to modify your equation, right? You're asked to modify your work to reduce the equation. This is b. You have to reduce this equation now. Minus 5y squared plus 24 square root 13 x plus 16 square root 13y equals to 32. Now you can quickly see some similarities in this equation, right? So what you realize is that all the steps will be the same, right? Because you will come to the x, the y, the matrix will be the same. Okay, if you want, let me rewrite how the system will look like. It will look like this: 0, 6, 6 minus 5x plus 1 over square root 13 of 24, 16 x, y equals to 32, right? And if you do all the simplification that we did before, you will come to this equation here, right? And plus, now this term here, right? If you also do all the simplification that we did before, you will have that it will be 1 over 13 of, right, of 24, 16 times 3, 2 minus 3 to x, y equal to 32, right? And this you can, simplify this. We know already this one will give us 4x squared minus 9 squared. We found this previously, and this one will give us 1 over 13 times 72x minus 48y, right, plus 32x plus 48y equal to 32. So this will give 4xy minus 9xy plus 1 over 13x equals 32. So this is 4xy minus 9xy plus 8x equals 32, right? So if you complete the square with the x variable, you have that this will give you 4xy plus x and yeah plus 4 minus 4 equal to 32. So this will give you 4x plus 1 square minus 9y square equal to 36, right? So at the end of the day, you still have a modified equation, but still the nature of this equation is what? It's an hyperbola, which you can easily sketch, right? I hope you got the main content of how to identify a sketch from the quadratic equation and what are the steps to follow in order to sketch the quadratic equation and to determine the new axis. Thank you very much.